Hey you, how are you doing? Hope you are doing good. Today's topic is all about .NET Reflection. Now this .NET Reflection, this feature is what we have always been using without even noticing that. So in today's lecture, I can really promise you that this feature will be clear to you and you really know why this feature is so much important in .NET. So before I deep dive into .NET Reflection, without even explaining what is Reflection, let me get into a Visual Studio project and let me try to do something for you. I'm going to be creating a .NET console application. This feature is not limited to .NET console. This is a general feature of .NET. This can just be anywhere, whether you are using web, Windows. This is a feature of C Sharp. That means .NET Reflection is omnipresent, can be used just anywhere. So let me create a .NET core application for now, a console application, and go for the next. Okay, let me name this as Reflection in .NET. Okay, and let me create next. Okay, I'm using .NET 8 for now. However, I can use .NET 9. That depends on your choice. Doesn't matter. And I'm going to be using, not going to be using top level statements. The project is on our way. Give it some moment. Great. So now your actual demonstration starts. In Visual Studio, you have always been seeing one interesting thing. Let's say if I have a string class or whatever, string x equals to my name, Shudipto, it's fine. And then if I write this x dot, how is Visual Studio giving all these intelligence? How is this really coming? All this intelligence. Do you have any answer for that? Just pause for a moment. Just think about it. That you install Visual Studio, of course, that's around like 15 or like 14 or 15 gigs of space. But the question is that why, you know, why exactly this Visual Studio automatically gives you all those senses? You might say that Visual Studio was pre-installed with them, right? This is what is your thought, that maybe that Visual Studio already knows them, right? That two upper function, the string contains two upper, two lower. You might think like that, right? That Visual Studio already knows them. Well, the answer is no. Visual Studio do not know anything about the string class. I repeat, Visual Studio knows nothing about the string class. Now, if you create your own class, let's say, well, class person, and let's say I have some functions. Okay, I'm going for the AI tool, and I had just some functions here, some properties and functions. Now, let's say if I now create a person class object, person P and new person with some default values, and then person dot, how again Visual Studio is giving these things. By the way, you might think that how am I getting these things automatically? I didn't write a bit of code. This is because the GitHub Copilot has been installed. This is an AI tool that automatically generates code, right? If you disable this AI tool, then you will not get anything of them, right? So this is just because of the AI tool. But I'm not talking about the AI tool. I'm talking about the IntelliSense, which has been the feature of Visual Studio since ages. So again, if I hit dot, you will see that automatically Visual Studio is sensing me this name, introduce, age. How are these coming? How Visual Studio knows them? Visual Studio has, some way access to the person class properties and variables and functions. How is exactly Visual Studio doing them? This is where comes the concept of, the .NET reflection. Okay. Now, let me little bit give you some broad overview of what .NET Reflection is and what it can do for us. I've got some note, so I have already prepared this note for you because this is little bit, intensive topic. So for the sake of time, I already have them in front of me so that I can copy and paste and can easily explain you all through. So a .NET reflection. What is .NET reflection? Well, .NET reflection is a very powerful feature in .NET framework that allows programs to inspect and manipulate their what? Their metadata and their objects in the runtime. Let me get it down. Now, what it really means that .NET reflection is a powerful feature in .NET framework. Of course, we understand it's a powerful feature. But what it does, it allows programs to inspect, that is to read, inspect, and manipulate their own metadata. What is metadata? Metadata means data about data. That is to explore oneself. The explore oneself means the program can automatically explore the classes fields, classes properties, classes functions. This self exploration is what is reflection. Okay, so when you can self explore yourself, the kind of you are reflecting on yourself. So you are dynamically knowing your properties, your functions, your methods, and that happens all in the runtime. You don't have to be doing, you don't have to be thinking it in the compile time. This is not something a compile time behavior. This is a runtime behavior. So .NET reflection is something that you can do in the runtime. And all these things will be super clear to you, I promise you. But first, let me go for that what it is used for. You can inspect types in the runtime. You can explore assemblies. You can explore classes, properties, methods, fields, etc. All dynamically. Dynamically means in the runtime. Nothing is in the compile time. You can do it all in the runtime. Dynamic invocation. You can call methods, access properties, fields without knowing them at compile time. That is, you don't have to know that what type it might be, what are those fields, which function you will call. You don't have to be knowing it at the time of compilation. You can decide at the time of runtime. For example, well, let me give a very simple example. Let's say there is an object X. Okay, let me a little bit enlarge this. Okay, there is an object X of certain kind. Object X of class, let's say class animal. Okay, now you really don't know which method will be invoked. There can be a lot of methods in the animal class. Let's say we might have eat, we might have sleep, we might have run, we might have breathe, right? There are so many methods of animal class. We really don't know which method to call. Like let's say there can be eat, okay, there can be x dot, sleep. I know that I'm missing those parentheses. They might have some parameters as well, right? There are so many methods, dot, whatever, like, run. But you really don't know which method to invoke in the runtime. You really don't know. It can just be anything. And also, some methods take parameters, some methods don't. Okay? So the idea is that if in the runtime, the user can type that which method to invoke. Think about it. In the runtime, user can tell that, oh, I want to be invoking the eat now. And we will do some code so that eat can be called. In the runtime, the function call will be determined, not in the compile time. Not in the compile time. There can be hundreds of functions within animal class. We are not going to do any such switch case statement that is taking a user code and saying if the user has entered, let's say if the user has entered choice equals to 1, let me invoke eat, and if the choice is equals to 2, okay, else if the choice is equals to 2, let me invoke sleep. No, we are not going to be doing this. This is quite nonsense, like this can be very cumbersome. This is not good, and even functions can change over time. So we are not going to do something like this. what we are going to do is ask for the function, inspect if the function is present within the animal class or not. If it is present, just invoke it. Okay, just invoke it. This dynamic invocation is one of the important thing of reflection. Reflection is a feature by which a class and an object can inspect its methods, inspect its properties, inspect its fields, even can inspect its private fields, private properties, constructors, private constructors, everything. You tell me, you think it does. So reflection is a way in which a .NET class or type can automatically know itself, knowing oneself, and then can decide what to do. You don't have to be doing something. Even you can just list all the methods that are available within certain class. Let us look at them with some example. But before that, I have just made this note. You can pause the screen and you can really look at it, what it does. It helps in late binding, custom attribute reading, can do serialization and deserialization. And the typical use cases are like creating plugin system, accessing private fields in testing. Yes, let me tell you, you can access and modify private fields by a .NET reflection. It allows using object relational models like entity framework and writing your own dependency injection container. So don't ask me that what for .NET reflection is used for. So I know people ask, for that I have already made this note for you so that you can have a note. Now I have already got these examples too, so that I don't have to be spending time too much. So this is the first simple example of using .NET reflection to inspect a class. Now I'm going to be copying and pasting these codes in my Visual Studio. There are a lot of code. I'm going to be doing it one by one. So by now that you understand in its basics that what .NET reflection is the capability of .NET to inspect on a type. That's it. It's a capability of .NET to inspect on a type. Type means it can be a class, enum, delegate, anything. You might know from your primary understanding that in .NET you have 5 types of .NET, 5 types in .NET. Okay, so what are they? First of all, we have class. Second, we have got struct. Third, we got enum. Fourth, we have got interface. And the fifth is delegate, right? So these are the 5 types in .NET. Now you tell anything that has to be among these 5 types. There is of course a record type too, but I'm not including that into here. So class, structure, enum, interface, and delegate. Any type, given any type, it can reflect on itself. If you say string, you can know all the properties that string class has. Okay, let's look at it. The first thing to do to go into .NET reflection is that we need this system.reflection namespace. So let me go and copy this, and let me come up here. Let me delete this, like I don't need it anymore now. Let me remove this. Let me also remove this. Okay, the very first thing is to introduce this system.reflection namespace. Okay, and now what we need to do is that I need to be having this class. So all we intend is to reflect on the methods that are there in this class, methods and properties that are there in this class. So this is a sample class, okay, a person class having name and age, and a say hello as a function. It just says hello. Our intention is not to call this for now. Please hold on. We will do that definitely. For now, our intention is to look dynamically, just like Visual Studio can do, like person p equals to new person, and then if you hit p dot, how is Visual Studio knowing the presence of all these functions and properties within this? Visual Studio is internally doing .NET reflection. Okay, so We are going to be doing that, but before I do anything, let me write this console.read key so that our code doesn't go past this. Let me come up here and let me close this. Okay, let me come up here and let me copy this code. Let me copy this code. Copy this code. Okay, don't worry, I'm going to be explaining you this bit by bit. So the first thing is, don't look at all the things together, just look at the first thing. There's a very powerful class in .NET which is type class. Type. What it does? The type class can basically read the type of any .NET type, like person. So we are all saying that type of person. That means we just want to know the type object pertaining to the person class. Every class can have its own type object. If you say that type q equals to type of, let's say type, oh my gosh, type of string, this immediately will give you the type of the string class inside q. Okay, so type of a class name will be giving you the type representation of that particular class, or I've already told you any type that can be a class, structure, delegate, interface, anything. So that means anything you think, anything, it can be a delegate, it can be a class, it can be an interface, they all will give you a type object that uniquely identifies the type of that particular data type. Okay, so what type does? Type is a kind of identification of that data type. All right, so type of string will give you an unique type object, and this q will point to all kinds of strings. Okay, so be it any string, has an unique type object associated with it. Any person object has a unique type object associated with it. Here the variable name is also type small. We have written it in small. Okay, I hope that you understand the point now. So after this type object is we have obtained, we just want to know, using the .NET reflectory feature, we want to know that what this type is all about, the type.name. Okay, the type.name is nothing but the person class's name. So let me comment this first. Okay, let me comment this first, and let me run this to show you that this just prints string or system.string better. Okay, oh, I'm sorry, person class, because we are all dealing with the person. See, if I run it, it will just show, it will just come up with the answer of dot reflection in .NET, which is the namespace. Usually sometimes it also refers by namespace, but this time it just did that class is person. So the name of the type is person. That is all it said. It was absolutely fine. You understand this? So type's name. So the type's name is nothing but the person class. If I happen to write it as string, okay, and then run it, you'll see it will now write string, because it is encapsulating the string class, right? You got it? So the type name, we have got several other things also. Type.name, type.fullname. If you write type.fullname, this will go qualify it completely from the namespace, system.string. All right. So I hope that you're getting a sense of it now. If not, please tell me, give me comments. So now if I, sorry, if I go about writing this person, then this person class is already present within this .NET reflection in .NET namespace, right? See, I've written this inside the system.NET namespace. This tutorial assumes your basic understanding of C# knowledge, the C# concepts like namespaces and basic data types, right? This is what I'm assuming. So, this is all for the general public. I don't know who you are, so please bear with me if your knowledge of basic C# is limited. Then you can go back and see some of my basic videos as well, or you can ask for a one-to-one class for me with me. So let me just run this now and show you that this time it will just say reflection in .NET dot person. I hope that you understood the point, right? Reflection in .NET dot person. That means the full name will qualify its full class name. So you can little bit, do some experiments. You can see there are several things. You can even say that what assembly you are there, the assembly, assembly dot, you can say assembly full name. Assembly is the name of the library. We are all inside reflection in .NET. So the assembly is also named after the project name. So no wonder this is going to give you the reflection in .NET, the version, culture neutral, public key token null. So I hope that you got the point that how exactly we can wrap up a type and then can inspect the type's information. Now there are more to it. Just just instead of like reflecting on the type name and the types assembly, there are more to it. This is all we are going to do right now. So type, oops, dot full name. Let me keep it full name. Okay, after that, we are doing something very cool. So we just want to know all the properties that are there within our type. The first thing we did is type dot get properties, and we got the property info. Okay, type dot get properties, this guy is going to be giving you property info array. I just want to break it down, okay, for your convenience. Var prop array equals to this get properties. Okay, so type dot get properties, can I enlarge this for your convenience? Okay, so type dot get properties, this is going to be giving you a property info array. Now on this array I'm going to loop prop array, and now when I'm looping on this prop array I'm getting individual property info objects. Okay, so what it does, what this is doing, this is basically iterating through all the properties this class has, name and string. For now we just have two. I can just have two functions, say hello, say bye. Okay, so we have got two properties and two functions. So here you can see that to get to all the properties that is name, we first have to be calling get properties, get it to the prop array, and then what we do, we loop through those properties. Now what are they? Prop objects. This prop object is the metadata information about the properties. So metadata is data about data. So using this prop, we can actually know what this corresponds to, what this property is all about, what it is its data type. Look at this. The next line is this. Prop name is what this prop object is, object's property's name is all about, its name. Okay, and then it says that what is the property type name. So prop that property type is again going to give you the type object. What type object? The type of the property. In this case the property's type is string. For the age, property's type is an integer. So what it basically does is, so prop.name will be giving you the name of the property, whereas prop.property type will be giving you the property's type. This is not the type of the person class. Remember, person class is of type person, right? Its type encapsulates the person class itself. Now we are talking about the individual properties and fields types. Okay, so that's for that we first have acquired the property array. All right, so this is basically property info array. I should say property info array. Okay, let me change the name. Yeah, property info array. And for all property info we have these props, so they are individual property info, prop info. I can write prop info, okay, to be clear, prop info. So on that prop info, I want to know, hey, what's the name of the property you are wrapping? And then what's the type of the property you're wrapping and its name, right? This way we can loop through all the properties and we can know their name and their type. The same for methods. What it does is, first of all, we need to be calling the get methods, but now there can be a lot of methods, okay, lot of methods. So what all we are doing is that we are saying I want to be getting those methods which are public, which are instance methods. There can be instance methods and static methods as well inside a class. So these are basically the flags, okay? These are flags. So this checks in all the binding attribute flags, okay? These are flags, and we are providing all the flags, like we want all the public methods, all the instance methods, that is non-statics, and only the declared only methods, right? So we have given all these flags, and then we would like to know what all our method info array is. Just like this guy was giving you a property info array, this guy is giving method info array. Now I'm not going to get it into a separate variable and run the for each. You have already understood the point. So now we are looping through, and all these methods are basically method info, and for every method we just want to know the name. So method dot name, okay, method dot name. But apart from method dot name, it is equally possible to have the method dot, we have method dot get parameters. Do you see that? Get parameters. So that means this again is giving you parameter info array. So that means we can get all the parameters within the methods. So let me get it, all the parameters. So this way you get a parameter info array. So I can just write var parameters. Okay. So that means we can really know that what this method actually takes in, all the parameters that this method takes in. So I'm going to be looping through that like for each. Okay, I should have stopped this, GitHub profile while illustrating, but sometimes it is really great. So for each param in parameters, so let me accept that, and it says parameter name and parameters name dot type. So that means we really like to know that what this parameter is all about. Now here we just have all empty. We can introduce something like, let's say, string name and then hello and then name. Please remember, we are not calling the method. We are trying to read the structure of the class. So reflection is all about reading the structure of a type, that what are the properties, names, fields, functions, and if you have got function, what parameters it has, what is the return type. We can know everything. We can just have everything. Let's say we have this as a return type string. Instead of writing by, we can just say by and then the name, maybe string name. So we like to return by plus name. Great, right? So in this way, this is equally possible for us to know not only the input type, if any. I mean, if there is no input type, then this for each won't really work. But also we can also know, we can really know the return type as well, the return parameter, the return type. See, the return type. We can also know the return type, right? So return type. If you hover the mouse cursor, it just gives you type object itself. So we can just write, like returns plus return type dot name, or full name probably, right? So for every method, we like to know that what it accepts. Okay, so this is the method, this accepts. So I just don't want to write this right line. So these are the parameters I like to after writing the method name. Okay, give a little space, and then say parameters. Here we can write parameters. These are the parameters. Okay, and finally we can say returns. So that means we like to write returns and also like to have a write line. Okay, write line. So this way it can really show you up all the methods, the name of the method, and then side by side we like to know all the parameters. Okay, and after that we also like to know what it returns, and that finishes one method definition. Then again it goes and for eaches through, gets the next method and writes the name of the method, reads all the parameters in that method, writes it down one by one, and finally writes what it returns. Let me run this and show you for you. It will do both for the properties and for the methods. Here we go. Look at this. So properties name, which is string, age, which is in32. Now look at this method. Get name parameters. Return. You might think that where are they coming from? Let me tell you, if you don't know, in deep inside .NET, there is no concept of properties. Properties are evaluated to functions. So you had a name property that got evaluated to get name parameter and set name parameter, like that. So that is why you are actually seeing get name, set name, get age parameter, set age parameter, and after that you also see that say hello. Say hello. Actually, I have missed one little space here. A little space would be great. Little space here. Little space here. Okay. Now look at this. Okay. So get name and the parameters are, there is no parameter to get name and it returns system.in32. Set name parameter. So what parameter? We have a string parameter value, the name of the parameter and the type of the parameter, and it returns void. Okay. Now if you go for the say hello, it has got a name input which is a string and it returns a void. Look at this by. It takes a name parameter and returns system.string. This is why .NET Reflection is so great. You can automatically look into and reflect into the .NET type, all the type. I can just change this immediately from person to string. Just what all I'm going to do, I'm going to change this to person.string. Okay. Now, if I run this, you'll be taken aback to see all the string classes properties and functions. All the properties and methods, they're all being listed. Here we go. Let me enlarge this. Look at this. Look at this. So properties, cats and length are the two properties of string class only. We majorly use the length, but have never used the cat so much. And now see, you see all the functions that string class supports. To lower, to string, substring, split, right? And we did that using a dynamic feature in .NET known as .NET Reflection, right? Hope now the points are getting more and more clear, right? So this is why .NET Reflection is so much powerful. Let me get into more examples. This is how you can invoke a method. Now, it is not only possible to list methods, it's also possible to invoke a method dynamically. This is so much of fun. We can invoke method dynamically. So we already had this person class, I believe. Okay, we had this person class having say hello. Okay. Now, how about if I really want to be invoking this dynamically? Now, I already have this main doing the task. I don't want to distort this. So I want to be naming this main as main1. Doing main1, .NET is no more going to execute it. So I'm going to be writing another main for your convenience. So this is main now. And of course, going to keep this console.read key so that the line never goes past this line. So we have this main now. Now what all we want is to invoke our person classes say hello dynamically. Now I have already got some bits of code with me. Now this code doesn't have any input parameter, but this is absolutely possible to pass input parameter. First of all, let me copy this code and run this. Okay, let me copy this code and paste it here. Okay, all right. First of all, let me have a method with text and nothing at all. Say hi, right? This text and nothing. Like to make things simple first. Hi, and then the name of the person. No name of the person. This is just hi. Just saying a general hi. Hope you are doing good. Right? So this is a function. This function once called will be giving you this output, but we don't want to be doing this just by writing this code like person p and p dot say hi, right? We could have done this so easily, all right? This is what we always have been doing. You can fill up with your name. So Aslin, for now, we can just have any name. Okay, I created this example with my student Aslin, so therefore this name is still there. Okay, so let me run this and you will see, say hi, hope you are doing good is coming, right? But this name is not taken into account, right? We can easily take this name into account and you don't have to worry about that. We could have easily done this, just by right by accessing hi here. But the main concern is not about even creating this object with some properties. I just wanted to call this say hi and then this runs. Now instead of doing it this way, we can do this way. Then this is compile time. Okay, if I can do this way, this we can always do this. We have always been doing this. This is the compile time. This is compile time. Compile time. Compile time invocation, right? But instead of doing this way, we really want to invoke it in the runtime. How may we do this? For that, okay, let me quickly copy this. The very first thing that we should do is we should get the type object of person. The very first thing is that we should get the type object. We should never think about the person object first. Though we can create the object first, we need to create that object though. But the first thing is that we should be extracting the type object of person. So we got the type object of the person, got it into this type. All right, great. And then using this type object, we can, first option is to get the method info of the method that you are calling. So please follow me. The first thing is to create the type object of the person class, right? We created the type object, great. Now from the type object that we created, we need to be extracting the method info. So here we are actually trying to get the metadata corresponding to the say hello function. We cannot directly call say hello function using .NET reflection. All we first need to do is to get the metadata of say hello, right? And this is obtained by just by invoking the get method function on the type object. So we got this say hello. We just want to say that, is there any say hello there? If it is, please give me. And the next thing that you should definitely check, if the method is not null, because there can be a time when you have misspelled it, so this will be null. So we should first check whether this method is still there. So method is not equal to null. That means there is some method. Okay, there is some method. I mean, there is the method with this name. And next we should call it. Call it by writing method.invoke. But the method is asking, hey, you want me to be invoked by methods are always invoked on an object. So instead of having the object.method call, here the system is just opposite. Method getting invoked on this object. How funny, isn't it? You know that in general we have object dot method call, but here the method info object is first extracted by calling get method of and also mentioning the method name on the type object. We get the method info object, which is the metadata of that method, and using that, using that, you can call it m, it doesn't matter. Okay, using that m reference, we are now going to be invoking on m, but the m is curious to know that on what object is it going to fire, for which object is it going to work. This is how we can invoke methods in .NET all dynamically. This is the powerful feature of .NET reflection. Please remember. First thing is P and the second is the argument. It doesn't take any argument, so it is null. Right? We are soon going to be giving argument. So m.info. Let's go and check it now. What it says, parameter count mismatch. Oh, great. Just because I have invoked the wrong method, it should have been say hello. So what it says is that you are trying to call say hello, but say hello is really taking some parameter. So I should give it parameter. I'll right now show you how to give parameter. But for now, let me call a a void parameter function that is that is a parameterless function. Say hi. So I should just say hi. Okay. It will get the method info and then trying to call on it. Here we go. Hi, hope you are doing well. You are doing good. I know you, man. Okay. So the next thing is, let's say I have done a spelling mistake. Say hi. Okay. Double H. I. In that case, this will return a null. So let me write an else and then say method not found. Okay. This doesn't give you an exception. It just says that, okay, you wanted to access this say hi, but I didn't find say hi. So this will be returning you a null. So null is returned in case the say hi isn't present. So as I run it now, you'll just see the method not found, right? So, yep, and it works. Now what if I really have to be executing a function which really accepts some parameter? Okay, in this case, all you need to do is that you need to be passing an object array here. Yes, so you can just write new object array and then pass the exact number of argument and the correct type to this function. So now that you know that this guy really exists, you really need to be exercising the call on this P, but you're now wanting to pass in some name. Let's say I want to be passing Shudipto, my name. So that means this say hello, which is this class, this function, would take one parameter name. Okay, so the first parameter, it just got one parameter. So if it got two parameter, you can have two parameter, like let's say name and int age. Hello name, you are age, sorry, you are age years old. I should have used interpolation. Age years old, right? So the point I'm trying to clear is hello name, you are age years old. So all I'm doing is that Shudipto, okay, and the next parameter should be matching with the parameter requirement of this particular say hello. Let me say I'm passing 44 as of now. All right. So Shudipto 44, and these parameter will be passed in the same order in which this function has been created. So the name will be coming here and the age will be coming here in sequence. Okay, let me run this and you now see it really works. And hello, Sharito, you are 44 years old, right? Great. I hope that you are getting the point. So that's the point. I hope that you are slowly grabbing the sense. I know you still are having a lot of questions and doubts. Let me tell you, this is very normal with .NET reflection. When I studied .NET reflection almost like 15 years back, then I was like, I was not able to make any sense of it. Then I slowly understood the point. The .NET reflection is all about reflecting on its type and the ability to invoke methods, classes, properties, functions, anything, all in the runtime. So this doesn't say that you need to be invoking, you need to be having a fixed type. It has just given you that flexibility that you can have any number of parameters, but be sure that whichever method you have now currently selected, it must match with it. Let's say if I pass in another thing, like let's say hi, okay, if you try to run it, it will say mismatch, like as we have already seen that parameter count mismatch. Okay, so what it just says is that it could really locate this say hello, but you are passing in three parameters, but the say hello isn't, doesn't contain three parameters. Okay, so I hope that you are getting the point now. All right, now I have got more examples. This is very same as we just did, like add method of calculator in getting invoked with two parameters, right? Invoke with two parameters, you can see. So passing in two parameters, right? The third one is invoking a private method. Now this is really interesting. Now look at this code. We have a class secret and I have a function whisper having a message MSG. Now, usually you cannot call this function whisper because it's a private method. You all know that. But look at that, what we are doing here. Secret class, we have created an object of the secret class, then we extracted the type. These are the two things that you always have to do. Create the object of the class that you're going to be inspecting or invoking methods. There are two things that we can do, either inspecting or invoking some, or do some work on it. Means doing some work means invocation, properties invocation, method invocation, fields invocation. So the first two things are to create the object and to get the type of that object. And then we are trying to say that method type, I'd like to get the whisper methods of you. Now we are also telling a very important binding flags. We are saying that the method should be, this method is non-public, which is private, and this is an instance method, which is, it means that this is not static. Now once we say that, we are uniquely going to catch up with the method. We are uniquely going to catch up with this method, and then we first make sure that it is not null. That is, if we had done any spelling mistake, this will not work. And then we are invoking this method that invokes secret, and we are also passing in, this is a secret message. I'm quickly going to show you this. So let me copy this and let me come up with this. Okay, very interesting. You know that we can never call a method, private method of an object, but the first time I am telling something not so usual, right? So let me come up with this code and show you this is absolutely possible to call private method. Okay, so we have a secret class object, we extracted the type. Using that type, we extracted the function. We also mentioned the flags, that is, it is non-public, and this is, what is this? You might know this. This is piping symbol, of course, and this is basically used for any enumerated constants. We use them for flags, okay? And then we use both of these flags to make sure that we can really point to the whisper function, which is private, and which is, of course, instance method. And then we want to, if the method was found, then we would like to invoke this method on the secret object and pass this parameter. Let me show you how it works nicely. You have successfully called private function for the first time, right? So this is completely possible. You can even access and change a private field. Oh my gosh, can you believe this? Look at this. What you can do is that, look at this. We had a private field, so password, and then we have this object. Then we said, now to access a field, we need to be get using the get field. Just like get property, get method, we got get field. Then we say that we are trying to access this password field, and we have to be giving those binding flags, that is non-public and instance. And then the same thing, we first make sure that we are successful in accessing this password field. And then what we do, we can read this by calling get value. But again, it will like to know on what object you are calling it. So field, this is basically field info. And you are seeing that this field need to be called on this user object, and thereby getting the original value. We can print the original value. And also we can change the value. Can you believe this? The dotted reflection can wreak havoc on an object. It can do any changes. So using dotted reflection, you know, all your all your wish of object encapsulation and all these things go in vain. So think about it. So dotted reflection is a very powerful feature. This is not for all. Okay, this is very powerful feature. This can read internal data of an object even if you have made private. So this can sip into, this can read value, it can come out. Okay, so dotted reflection should be used with care. So field dot set value user new password. So we have set it, and then after that updated password, we can just read it by using the same thing, read value on the user. Let me quickly use this. So let me quickly create another class, and then making it main3, and okay, let me copy this. Let me write it. Static void main, static void main. Also introducing this console.read key. I think by now you are getting a full understanding of, at least to some extent, that what this dotted reflection can do. Let me copy and paste this code. And now you can see that we got the user, we access the type. From the type, we want to access this password field, which is this password field, right, which is private. We access this password field, and then we like to make sure that the field was accessed successfully, and then we like to call the field on this object. It's just like the opposite one, right? We know that object used to call on its properties, on its method, and then the first we decide on what to call, and then we say that you are going to be called on this and this object, right? So field is going to be called on this user, and we got the original value, it was printed, and then we are using the field to call the set value, but again saying that you are being called on this user object, and then passing the new value. After that, we're again using the field.getValue user to see the updated value. Great. We have successfully modified private field. It was secret 123, and now this is new password 456. So how strong can reflection be? Just take a time and think about it. The last thing is all about invoking a public constructor. Absolutely possible. So that means we can create object all dynamically. Invoking a public constructor means you can create an object dynamically, right? I already have many classes, so I like to copy this code directly and show you that how we can directly create an object not using the new keyword. Okay, I think we already have main 3. Let me make it main 4. Okay, fine. And there we go. So we are starting off with the type object. We even not creating the object. We are saying that we have this type object. We haven't used the new keyword. We are now saying type dot get constructor, and then see there can be many constructors, but we want to say that we want to get a constructor whose parameters are like we just have one parameter of the type string. Now we can get into the person class. You see we don't have any constructors as such. Okay, let me quickly create the constructor for you. So this is the constructor, right? All right, so this is the constructor. Fine, let me have another constructor. Yes, great. I'm being heard, and GitHub Copilot is hearing me, is listening to me. So I've got two constructors. One constructor having the name, second constructor is having the name and age. So what we are doing is, so we want to be creating, we want to be using this type, we want to be calling on the constructor which just has one parameter, right? One parameter constructor, taking the string as the first argument. Using that, you have the constructor info. The same thing you can also do for the method info. I have missed that point. I will definitely show you. So get constructor, okay, and you can call this like that. So while telling get method, you can use, so now if you just have one method, you may not use this, but if you have two methods with the same name, that is overloads of each other, the two methods with the same name, two different parameter counts, parameter types, then you must identify that which method you want to get by giving the actual types, okay, the type that particular method or constructor takes. So type of this, great, and the constructor info gets the constructor, the same thing, the constructor was obtained. Then we are saying constructor.invoke, and then we are passing in this name. So what it means is that constructor dot invoke, you don't see the object being passed here because constructor never requires an object, right? Once the constructor gets called, we actually get the object. It's the other way around. So you can see the constructor dot invoke, and then we are passing in the value. This is the real value we are passing in. That creates the object, and after that you can really inspect the object, that okay, this is the object, we casted it to person object and we'd like to know the name. That should print ASLN, right? So let me console dot read a key, then run this. Oops, there's some mistake. What mistake, Mr. Visual Studio? Okay, one of the error in summer up, because now the person class don't have a default constructor. I like to sprinkle a default constructor there. So ctor, okay, just had the default constructor, because you know that once you have some parameterized constructor, the default constructor is withdrawn from the class. So therefore the default constructor was gone. So that's why one of the module started showing error, but now no more. So one more time, we use the type to get hold of the constructor, then we called the constructor, then we invoked it. We got the object in the object type, not as a person type. You never get it. You will always get in the general type. You need to be doing the casting to get it in the right type, and then you can read the property the way you want, right? So let me run it and show you. It just writes ASLN there. Great, lovely. Now, one of the function that where I was invoking method, there we go, in the method 2. So we are invoking say hello, right? So we had a say hello there. Now the say hello method here got name and age. We are pretty sure that we just have one say hello. What if I had two say hellos? Just that one will just take one parameter, the second will just take two parameter. So this is just one parameter say hello. This is one parameter say hello. This is two parameters say hello. In this case, I like to uncomment this code. Uncomment this say hello. Okay, this mean to which was calling this say hello, right? And invoking Shudipta and 44. So let me uncomment this. I mean, let me just revive this by calling it main. And let me call this as main 5. Okay. Now also minimize everything. There's a way in .NET to Visual Studio to minimize all the thing. We can use Control MO to minimize all of them. See how beautiful, isn't it? And Control MP to expand. So MO for minimizing. Great. So now I need to be looking into this code. So at this point, we are trying to access this say hello, but say hello has got two overloads, that is two versions. You need to be good in object orientation before you could have come to this tutorial. .NET reflection is quite an advanced topic, but it is easy to understand, no worries. At this point, the system will be getting confused that which say hello to call. If I say hello, and if I want to be passing Shudipta and 44, there's a reason of it to get confused. See, ambiguous match for .NET person say hello in 32, right? Is not able to get that you are trying to get in two values, but now I am super confused that which one to call. There comes the rescue. You can actually write new object array and then pass in the types. So you can say that I want to be calling that say hello, where the first argument is the type of string and the second argument is type of int. If you write that, am I doing any mistake? Get method. Let me quickly look into that. The constructor part of it. Okay. New. All right. Type dot get constructor. Type dot get method. All right. Type dot get constructor. Type dot name binding flags. There are a lot of them. And we also need to be saying that method count. We need to be, just a moment, let me quickly look into it. Oh, I just need to write new probably. I don't need to add new. Yeah, now it looks good. Just new. You don't have to say new object. No, just new, because they all are new types. Okay. Now let me run it and see our outcome. Here we go. It works. It works like a charm, isn't it? So if we are not sure that which method to invoke, if you're not sure, the runtime won't be sure too. So you need to making sure that which function to invoke by presenting it the parameter sequence. If the first parameter is a string, so that means get me to that particular function where the first parameter is a string and second parameter is an integer. It says, great, you have it now, and then you can invoke it, right? But if you try not to do that, it will be confused. It will not even be returning null. It will be confused. All right. If you write a wrong function name, this will say not found. Okay. Then this is not found, right? So if the function name isn't there, it just returns null. If the function name is there, but the parameters are ambiguous, it has a problem. Like let's say I just want to take off this. That is, I just want to be getting to a say hello, which has the first parameter as an integer. Do you really have such a kind of function whose first parameter is integer? No. Look at this. I don't have. I have the two version of say hello. The first parameter being string, second parameter is an integer, and the second function is where the first parameter is a string. So I really don't have any such function where the first parameter is an integer. So if I run it now, it says method not found. Okay, method not found. So it will just strictly say method not found. But if you don't write anything in here, it will be super confused because you don't know which one to invoke, and then that brings up to a confusion, right? But what if I don't write anything? Okay, that is an error. You can't do that. That is an error. Okay, so you need to be so you really need to be, I'm having a class, online class starting soon, so I need to be ending my lecture now. So new type of integer, okay, that won't be doing anything. But if I say new string, then calling this will be a nonsense because I have access to function which takes the first argument only, but now I'm trying to pass in two, which really causes a problem. Look at this, the exception, parameter count mismatch. So in this case, I could have taken this 44 out and then it will work. It will just greet me, not my age. Hello, Shudit. So that was it. I hope that you got a good idea of, to some extent though, I have tried my best to give some examples, rather many examples of how to be using .NET Reflection, what it is. So once again, .NET Reflection is all about reflecting on the .NET types. It's metadata, and you can inspect types in the runtime using dynamic invocation, late binding, other features, and all the ORMs like entity framework is built on the top of .NET Reflection, and you can create plugin systems. You can access private fields for testing, right? Because testers don't have a direct access, but if testers want, they can really inspect and test the private fields. That is one of the great feature. And you can also do dependency injections container. You can create your own dependency injection containers. There are a lot of reason why you might use them. You might find it many times coming up and up again. So hopefully that was all about .NET Reflection. So this is Shudipto. I've been doing .NET training for the past 20 years. I'm a Microsoft certified professional and teaching successfully my local students as well as online students. You can check with me if you really want to learn .NET. So that was all. I hope that you got a good time. Take care and bye-bye.